So the first thing you notice, if you were to somehow walk into this scene in the gray light of that morning, is just the total suffocating absence of sound.
Right. Which is, it's incredibly unsettling.
It really is. I mean, I want you to really picture the geography here.
Yeah.
It is August 22, 1986,
Yeah.
and you are standing in the lush, green, highly elevated hills of northwest Cameroon. It's dawn.
And dawn there should be loud.
Exactly. In a rural farming cluster of villages, specifically, Nyos, Cha, and Subundan is supposed to be chaotic.
Right. It's an agricultural community.
Yeah, it should be like this symphony of biology. You should be hearing, roosters crowing to wake up the sun, the heavy lowing of cattle moving around in the fields.
People waking up, chopping wood.
Right, the crackle of wood being split for cooking fires, children running out of doors. It should basically be a landscape that is just saturated with noise.
But the human brain, it simply isn't wired to process the kind of absolute silence that hung over that valley that morning.
No, not at all.
We are conditioned to expect disasters to be, loud. We think of earthquakes tearing the ground apart with this deafening roar, or floods crashing through ravines, or hurricanes tearing the roofs off houses.
Yeah, disasters are usually kinetic, right?
Exactly. They're kinetic. They announce themselves.
But standing in this valley, you only hear, like the wind moving through the tall grass. You might hear the creak of an unlatched wooden door swinging on its hinges. Or, your own footsteps on the dirt path.
And that is literally it.
That is it. There are no dogs barking. There are no insects buzzing in the brush. There are no birds singing up in the canopy. It is a dawn completely, comprehensively devoid of life.
Which brings us to the core of what we're doing today.
Right, exactly. We are looking at a stack of historical accounts, medical triage reports, and some of the most baffling scientific investigations of the 20th century in this deep dive.
Because our mission here is to dissect a catastrophe that almost nobody on the planet even knew was, geometrically possible.
Yeah, we are looking at a silent, entirely invisible event that killed 1,746 people basically overnight.
And leaving absolutely zero physical damage to the environment.
Nothing. And we're going to explore how the forensic footprint of this deeply unsettling event points directly to a massive, loaded threat sitting right under 2 million people today.
To really understand the sheer scale of the disorientation on the ground that morning, we have to look at the first responders and the handful of survivors.
Yeah, the early accounts are just wild.
There was this one man who had been traveling outside the valley the night before, and he came walking back down the dirt road toward his village.
And what did he find?
He found his neighbors, his family, his livestock all dead. And when he fled back up the hill to get help, his initial report wasn't that there had been a storm or an attack.
Right.
All he could articulate to the authorities was that everyone was just gone.
I mean, just the trauma of that. And when medical personnel and regional authorities finally arrived, the crime scene they were staring at made absolutely no sense.
Right, because of the lack of kinetic energy.
Exactly. If you have a disaster that wipes out 1,746 humans and roughly 3,500 head of cattle, you expect to see that kinetic energy we were just talking about.
You expect rubble.
Right, but it was like looking at a paused video game or the aftermath of some sci-fi neutron bomb that only targets biology.
Because the architecture was just completely pristine.
Completely. The thatched roofs were totally intact. The mud brick walls were uncracked. There were no high water marks, or mud deposits that would indicate a flash flood had rolled through.
No scorch marks, no ash, no smell of smoke.
So the absolute absence of physical evidence forced these investigators into a state of profound cognitive dissonance.
Well, what's fascinating here is how the absolute absence of evidence was the evidence. When you rule out tectonic shifts because the ground is undisturbed and you rule out weather events because the structures are untouched, you are left basically looking at the bodies themselves.
And the pathology of the victims was just as baffling, right?
Exactly. There was no blunt force trauma. There were no signs of a struggle whatsoever. The victims were lying exactly where they had fallen.
Mostly in bed, right?
Yes, the vast majority of them were still in their beds, having just passed away in their sleep.
I was reading through the medical reports of the survivors, and the anomalies they exhibited just make the entire scene even more surreal.
Yeah, the survivor accounts are very strange.
Like the few people who did survive didn't just wake up the next morning with a bad headache. Some of them woke up a full day and a half later.
Right, 36 hours later.
Yeah. They had been in this deep, unexplained comatose state for up to 36 hours. Some woke up just staring at the ceiling with absolutely no memory of the previous night.
And physically, they presented a very specific, strange cluster of symptoms.
Like the breathing stuff.
Yeah, many of them suffered from lingering, painful respiratory issues, like this intense burning sensation in the lungs and the throat.
Which sounds awful.
But the most confusing detail for the early triage doctors was the presence of severe skin lesions.
Okay, let's unpack this, because people had what looked like massive blisters or burns on their skin.
Right, which initially led some of the medical team to speculate that, some kind of chemical acid or heat wave had swept through the valley.
Yeah, I looked into those lesions specifically because a chemical burn just didn't track with the pristine environment.
No, it contradicts the lack of property damage.
Right. If acid rained down, the plants would be dead, the thatch roofs would be eaten away. But the vegetation was perfectly fine.
So what were the lesions, if not chemical burns?
It turns out they likely weren't chemical burns at all. They were a combination of two bizarre side effects of what actually happened. First, when people are rendered rapidly unconscious and lay immobilized on uneven, hard ground for 36 hours.
Oh, pressure sores.
Exactly. The restricted blood flow causes severe pressure sores that completely mimic blisters. And second, there's this physics phenomenon called the Joule-Thomson effect.
Ah, right. The thermodynamics of expanding gas.
Yes. Can you explain that a bit?
Sure. When a highly pressurized gas is suddenly released and expands rapidly, it actually absorbs heat from its surroundings. It gets incredibly cold, incredibly fast.
Right. So some of those lesions might have actually been localized frostbite.
Wow.
Yeah, the victims were hit by a freezing wave of gas that flashed over their skin, causing thermal damage that the initial doctors misdiagnosed as heat burns.
That is just wild. But again, all of this biological devastation is sitting in the middle of completely undisturbed trees and houses.
Yeah, the ultimate locked room mystery.
Exactly. So the immediate question on the ground for the authorities and the terrified survivors was basically, what is the mechanism? What invisible weapon just wiped out 3 villages?
And because there was no physical destruction on land and nothing fell from the sky, investigators had to look at the only variable left in the local topography.
The water.
They had to look at the water,
Okay.
specifically Lake Nyos, which is this calm, picturesque crater lake perched in the volcanic hills above the villages.
But even looking at the lake, the surface appeared relatively normal, right? Aside from some unusual discoloration and floating vegetation near the shore.
Yeah, just some slight weirdness on the water, but nothing that screams, I just killed 2,000 people.
Right.
So this triggers a frantic global scramble. You have scientists flying into Cameroon from all over the world to try and solve this mystery on a massive geological scale.
You've got volcanologists, geochemists, limnologists, which are, the experts in inland lake systems.
And the initial debate between these factions was incredibly fierce because they had absolutely no blueprint for an event like this.
No precedent at all. The volcanologists looked at the geography and naturally assumed a volcanic eruption. I mean, Lake Nyos sits in the Oku volcanic field.
Makes sense on paper.
Yeah, it occupies a mar, which is basically a broad, shallow crater formed by a phreatomagmatic eruption.
Which is when groundwater hits magma and explodes, right?
Exactly. So, assuming the volcano had suddenly woken up and vented toxic volcanic gases like sulfur dioxide or hydrogen sulfide, it made logical sense to them.
But the limnologists and the medical experts were looking at the victims and saying, wait a minute, sulfur dioxide smells like 1,000 rotting eggs. It's incredibly corrosive.
And the survivors didn't report that.
Right. They reported smelling something faint, sometimes described as gunpowder or rotten eggs, but not in the overwhelming, choking concentrations a massive volcanic vent would produce.
And volcanoes are messy.
Exactly. A standard volcanic eruption usually comes with heat, seismic tremors, and massive physical displacement of Earth. The seismometers in the region didn't record a major earthquake at all.
Meanwhile, the local population was entirely justified in their own theories.
Oh, absolutely.
When you see your entire community wiped out overnight without a single scratch on the buildings, and foreign scientists are swarming the area in hazmat gear arguing with each other.
You're going to think the worst.
Yeah, rumors of a covert chemical weapons test or intentional sabotage become the most rational explanation for a completely irrational event.
But the data ultimately led the scientific community to a consensus that required them to coin a term almost nobody outside of a hyper-niche academic circle had ever even used.
A limnic eruption.
A limnic eruption. They concluded that Lake Nyos hadn't been hit by a volcano. The lake itself had detonated.
The mechanism of a limnic eruption is, a masterclass in geophysics and fluid
It
dynamics.
really is.
To understand how a lake can explode without a bomb or a volcano, we have to look at what was happening hundreds of meters below the surface.
Right down in the deep water.
The final calculation was that between 100,000 and 300,000 tons of carbon dioxide CO2 had suddenly erupted out of the water.
I have been trying to visualize how you even trap that much gas in water. And the analogy that finally clicks for me is thinking about this lake like a perfectly layered cocktail at a high-end bar.
Oh, I like that.
You know when a bartender makes a black and tan and they pour the dense stout over the back of a spoon so it sits perfectly on top of the lighter ale?
Yeah, yeah.
The two liquids share the exact same glass, but because of their different densities, they completely refuse to mix unless you actively take a stirrer and agitate them.
That concept of thermal and chemical stratification is exactly what was happening in Lake Nyos.
Right.
In a typical temperate lake, the changing seasons basically force the water to mix. In the winter, surface water cools, becomes denser, and sinks to the bottom, pushing the bottom water up.
Like a natural convection cycle.
Exactly. This process, called lake turnover, allows any gases trapped at the bottom to gradually and safely vent into the atmosphere.
But Lake Nyos is near the equator. The temperature is relatively stable year-round. It doesn't have those drastic winter freezes to force the water to flip.
Furthermore, Lake Nyos is incredibly deep. It's over 200 meters deep, and it's sheltered from strong winds by the high walls of the volcanic crater.
So the wind can't even stir the top layer enough.
Right, so you have a thick, warm layer of surface water acting like a heavy blanket over a deep, cold, incredibly dense layer of bottom water. They simply never mixed.
And here is where the geography becomes totally lethal. Because it sits in a volcanic field, there is a pocket of magma deep within the Earth's crust beneath the lake.
Yes.
For decades, or perhaps even centuries,
Yeah.
that magma had been quietly, persistently leaking carbon dioxide gas up through the bedrock.
The CO2 basically bubbled up through the rock and dissolved directly into that cold, stagnant bottom layer of the lake.
It's charging it up.
Now, because of the immense hydrostatic pressure, the sheer physical weight of 200 meters of water pressing down from above, that bottom water could hold a staggering amount of dissolved gas.
It's Henry's law, right?
Exactly.
The amount of dissolved gas in a liquid is proportional to its partial pressure above the liquid. Basically, the deeper you go, the heavier the water gets, the more pressure there is, and the more gas you can cram into the water without it bubbling out.
The lake essentially becomes a massively overpressured storage tank. Over decades, the bottom layer of Lake Nyos became entirely saturated.
Just maxed out.
It was holding maximum capacity of dissolved CO2, kept in check only by the delicate, undisturbed weight of the water sitting above it.
It was basically an unpopped bottle of champagne sitting on a fault line. The liquid looks completely clear. There are no bubbles.
Right, it looks totally fine.
But the second you pop the cork, or in this case, disturb the stratification, the pressure drops, and all that gas violently comes out of solution.
Yes.
But what actually popped the cork on August 21st?
Well, that remains the most haunting, unsolved variable of the entire event.
We still don't know.
We simply do not know the exact trigger. The geological record of that night leaves us with several viable hypotheses, but no smoking gun.
What are the main theories?
It could have been a localized rockfall along the steep interior walls of the crater, so sending a boulder crashing down into the deep water and stirring it up.
Or heavy rainfall, right? I mean, August is the rainy season in Cameroon.
Yes, a massive influx of cold, dense rainwater hitting the surface could have sunk rapidly, essentially punching a hole through the thermal layers and disrupting the bottom water.
That makes sense.
It could have also been a micro-earthquake, too small to register as a massive tectonic event, but just enough to shake the water column.
Right.
Or, most terrifyingly, the lake might have simply reached absolute critical saturation.
Like it just couldn't take anymore.
Exactly. It couldn't hold a single molecule more of CO2, and the slightest natural current caused spontaneous exsolution, which is just gas naturally coming out of the liquid.
Whatever the microscopic trigger was, it pushed a small volume of that supercharged bottom water slightly upward. And as it moved up, the pressure from the water above decreased just a fraction.
And that slight drop in pressure allowed a few bubbles of CO2 to form.
Right, and those bubbles changed the density of the water. Bubbles make the water buoyant.
So the water rises even faster, which drops the pressure even more, which causes millions of more bubbles to form instantly.
It creates a runaway exponential chain reaction. Within seconds, A massive, violent column of gas and water is shooting toward the surface at this terrifying speed.
It was a full-scale limnic eruption.
Wow.
The surface of the lake literally exploded upward, creating a localized tsunami that scoured the shoreline, uprooting trees and stripping vegetation.
Which explains the weird water damage right at the edge of the lake that investigators saw.
Exactly. And out of that churning water surged an unfathomably massive cloud of invisible carbon dioxide.
Now, the physics of the gas from this point forward are what turn it into such an efficient assassin.
The gas behavior is crucial.
Yeah, if this had been a release of hot air or helium, it would have just dispersed up into the atmosphere, maybe causing some temporary breathing issues for anyone standing right on the shoreline.
But carbon dioxide is dense.
So dense. It is significantly heavier than the standard nitrogen-oxygen mix of the air we normally breathe.
When that immense volume of CO2 hit the air, it didn't rise. It essentially collapsed back down onto the surface of the lake, completely intact as a massive, dense mass.
It's like a heavy blanket.
And then, driven by gravity, it began to flow downhill.
I kind of picture like a reverse flood. You know, instead of water rushing down the valley, it's an invisible fluid of pure gas.
That's a great way to visualize it.
It poured over the lip of the crater and just rushed down the natural topographic funnels of the mountainside. Estimates suggest it was traveling at nearly 100 kilometers per hour.
As it rolled down into the valleys toward Nyos, Cha, and Subam, its density meant it hugged the ground perfectly.
Right.
It physically displaced the lighter, breathable air, literally pushing the oxygen up and out of the way.
It acted like a giant invisible wedge. If you were standing in the valley, the breathable oxygen was literally lifted above your head, replaced from the ground up by 100% carbon dioxide.
And the physiological response to environments with high CO2 concentrations is incredibly rapid.
How fast are we talking?
Extremely fast. We breathe in oxygen and exhale carbon dioxide, obviously, but our respiratory drive, the actual physical instinct to take a breath, is actually triggered by the buildup of CO2 in our blood, not the lack of oxygen.
Right, so if you suddenly inhale a lungful of highly concentrated CO2, your body immediately panics.
Exactly. It panics, but you are instantly starved of oxygen. At concentrations above 10%, CO2 basically acts as a severe narcotic and convulsant.
So it just knocks you out.
People would have lost consciousness in seconds, falling to the floor, which, tragically, is where the gas was most concentrated because it's so heavy.
The cloud just blanketed the villages, asphyxiating everything in its path. Every human sleeping in a bed, every animal in a pen, every insect in the grass.
Everything.
And because it was completely invisible, odorless, and silent, there was no warning. People simply stopped breathing.
And then, as the topography widened out and the morning sun heated the air, the gas eventually caught the prevailing winds, mixed with the atmosphere, and dissipated without a single trace.
Right, the oxygen just settled back down into the valley, the sun came up, and the landscape was perfectly intact, but entirely dead.
Which is what those first responders walked into.
But this brings up a massive issue for the scientific investigation. I mean, if the gas vanished into thin air, and the lake settled back down to looking like a normal body of water, how did the scientists definitively prove that a limnic eruption actually happened?
It's a fair question.
Like, how do you scientifically prove a ghost was in the room when all the evidence just blew away in the wind?
The proof ultimately came from rigorous long-term observation. The researchers didn't just pack up and leave when the bodies were buried.
They stayed to monitor it.
Yeah, they established monitoring stations and took continuous deep water samples in the years following 1986.
Yeah.
They tracked the dissolved gas levels.
So they watched the lake actively recharging.
Exactly.
They could see the CO2 levels creeping back up year after year because the magma was still leaking and the lake was acting as a sponge, filling up again.
The continuous measurements proved the mechanism beyond a shadow of a doubt.
But wait, didn't they find out something else while they were digging into the history?
Yes. The most chilling validation of the limnic eruption theory didn't actually come from the future data of Lake Nyos. It came from looking backward.
This part is so wild to me.
As the global scientific community was trying to synthesize this completely unprecedented disaster, researchers started digging through regional records and geological surveys.
And they uncovered a deeply bitter, entirely overlooked piece of recent history.
Right. If we connect this to the bigger picture, this is where the story shifts from a natural tragedy to a profound systemic failure.
Just 2 years prior to Nyos, in August 1984, the exact same invisible ghost had already visited a nearby valley.
Lake Mana.
Lake Manan. It sits only about 100 kilometers away from Lake Nyos.
It shares the exact same geological profile. It's a deep, stratified crater lake situated over volcanic vents leaking CO2.
And on August 15, 1984, Lake Manan underwent the exact same mechanism of a limbic eruption, just on a slightly smaller scale.
Right, a section of the lake overturned, a dense cloud of CO2 surged over the rim, and it rolled directly across a nearby road in the early hours of the morning.
And 37 people were killed.
37 victims.
Many of them were just locals walking to a nearby market or driving along the road. They simply walked into an invisible pocket of gas, suffocated, and died instantly on the dirt.
And when you look at it in hindsight,
My immediate reaction was just extreme frustration. I mean, how do 37 people drop dead on a road from an invisible force just 2 years before Nyos? And it doesn't trigger the most massive scientific alarm bell in history.
it's hard to reconcile.
How did we completely miss the warning?
It is the ultimate tragedy of scientific lag and the siloing of information. In 1984, the very concept of a deadly limnic eruption simply wasn't in the academic textbooks.
It just didn't exist as a field of study.
Right. Limnologists studied water quality in ecosystems. They didn't study explosive, lethal gas releases. Volcanologists studied magma and ash, not cold water stratification.
So it fell in the cracks.
The event at Manan fell into an entirely unmapped gray area between disciplines.
And because there was no scientific framework to explain it, the local authorities and the few researchers who did investigate were totally baffled.
And what happens when people are baffled?
When you don't have a natural explanation for 37 uninjured bodies, human nature basically defaults to human malice.
Exactly.
The region was swept with rumors of political sabotage, a targeted poisoning, or some kind of bizarre insurgent attack. The investigation stalled because nobody knew they were supposed to be looking for a geological assassin.
The hazard announced itself perfectly. It demonstrated the exact mechanism, the exact lethality, and the exact environmental conditions.
But because the scientific community lacked the imagination to recognize a brand new planetary threat, the warning went entirely unheeded.
The emotional weight of that hindsight is just staggering.
It really is. If the Manan event had been correctly decoded in 1984, someone would have instantly said, wait, lakes can trap gas and explode. How many other deep crater lakes do we have in this volcanic region?
Lake Nyos would have been immediately identified.
Yes. The deep water could have been tested. The local villages could have been educated on the warning signs of a water overturn or simply relocated.
1,746 people died at Nyos because the world didn't understand what happened to those 37 people at Manan.
So what does this all mean for us today? Because learning a lake can exhale death is terrifying, but learning it has happened twice means it's a pattern.
It fundamentally shifted how geologists and limnologists view the stability of the Earth.
Because patterns mean it can happen again.
Right. If a lake can spontaneously exhale death and wipe out an entire community, and it has happened twice in 2 years, that is no longer a freak anomaly. That is a measurable, repeatable geological pattern.
Which sparks a completely terrifying global audit.
Oh, totally.
Once they realized that Manan and Nyos were a matched set of environmental assassins, a frantic, highly funded global survey began.
Scientists needed to know exactly how many other lakes on the planet were secretly functioning as massive pressurized gas bombs.
So they tested deep waters everywhere, right?
Yeah. Everywhere. They looked at crater lakes in Asia, deep locks in Europe, volcanic lakes in the Americas.
And out of the millions of lakes on Earth, they found only one other body of water that shared this specific deadly combination of immense depth, tropical thermal stratification, and active volcanic gas leakage.
Just one.
Lake Kivu.
Lake Kivu?
For anyone listening who hasn't heard of Lake Kivu, this is the ticking time bomb of our story. This is the loaded gun sitting on the table right now.
Lake Kivu sits directly on the border between the Democratic Republic of the Congo and Rwanda.
And when we talk about Kivu, we have to talk about mathematics and scale, because the scale is almost impossible to comprehend.
To put it in perspective, Lake Nyos, the lake that killed 1,746 people, holds about 1.5 cubic kilometers of water.
Okay, 1.5.
Lake Kivu holds roughly 2,250 cubic kilometers.
Wait, really?
It is a massive inland sea. It is approximately 1,500 times larger than Lake Nyos.
If Lake Nyos was a shaken soda bottle on a kitchen table, Lake Kivu is a massive pressurized industrial brewery situated directly on top of a highly active earthquake zone.
That's a very accurate way to put it.
The deep waters of Kivu hold an estimated 300 cubic kilometers of dissolved carbon dioxide. I tried to visualize that volume.
It's hard to picture.
It is. If you take a cube of pure gas that is 1 kilometer wide, 1 kilometer long and 1 kilometer high. That is 1 cubic kilometer. Now multiply that by 300. That is what is trapped under the water.
The magnitude of the trapped CO2 is staggering, but Lake Kivu possesses an additional, entirely different layer of threat.
The methane.
Yes. The biological activity in the lake, specifically microorganisms breaking down organic matter in the deep, oxygen-free water, has produced an estimated 60 cubic kilometers of dissolved methane gas.
So we aren't just dealing with an invisible wave of suffocating carbon dioxide anymore. Methane is highly flammable.
Exactly. The presence of methane adds extreme volatility.
So if it erupts,
If a limnic eruption were to occur at Kivu, you wouldn't just have a massive, heavy cloud of asphyxiating gas rolling over the landscape.
Right.
If that methane broke the surface and found an ignition source, a cooking fire, a running vehicle engine, a spark from a power line, the atmospheric ignition would be catastrophic.
and the trigger conditions are far more precarious than News 2. Kivu is situated in the Albertine Rift, which is a highly active tectonic region.
It is physically ringed by active volcanoes.
Right. Mount Nyiragongo, which is just north of the lake, is one of the most active volcanoes in Africa. It erupted in 2002 and again in 2021.
The 2021 eruption of Nyiragongo caused a massive immediate panic precisely because of Lake Kivu.
I remember seeing the news coverage of that.
Magma flowed toward the city of Goma and the lake shore, and authorities were absolutely scrambling to monitor the seismic activity to ensure the deep water wasn't disturbed.
The fear wasn't just the lava.
No, the fear was that a tectonic shift would pop the cork on Kivu.
Because unlike Nyos, which had a few isolated farming villages in the valleys below it, Lake Kivu is heavily developed.
Very heavily developed.
There are roughly 2 million people living directly along its shores. Cities like Goma in the DRC and Gisenyi in Rwanda are teeming with life, infrastructure, and commerce right on the edge of this water.
It's a huge population center.
You have 2 million people living their daily lives next to a geological weapon of mass destruction.
Now, it is crucial that we frame this risk carefully for anyone listening. Lake Kivu has not erupted in recorded history.
That's an important caveat.
Sediment core samples suggest that massive overturn events have happened in Kivu, but they occur on geological timescales thousands of years apart.
Those not bubbling right now.
Right, the lake is not currently fizzing, and it is not showing signs of an immediate, spontaneous blowout tomorrow. It is a looming, heavily monitored risk under management, not an active countdown clock to zero.
We have 2 million people living next to a geological loaded gun. We can't just cross our fingers and hope a volcano doesn't shake it too hard, right?
No, definitely not.
We know the mechanism now. We know exactly what happens when these lakes flip. Did the global scientific community just look at the sheer size of Kivu, look back at the bodies from Nyos, and just walk away from this?
The sheer scale of Kivu does sound like an insurmountable doomsday scenario, but the story of limnic eruptions is ultimately one of incredible scientific redemption.
I'm glad there's some good news here.
Scientists and engineers didn't just walk away and hope for the best. They took the brutal lessons of Nyos and decided to try and literally diffuse the lakes.
Which brings us to the engineering triumph of the 21st century. Following the disaster, a French-led team of engineers and scientists proposed a wildly ambitious idea.
A brilliant idea, really.
If the lake is an overpressured bottle of soda, and the danger comes from popping the cap all at once, what if we just give the lake a straw? What if we let it bleed the gas out slowly?
They figured out a mechanism to mechanically disarm Lake Nyos. The concept is beautifully simple in theory, but the logistics of executing it in a remote crater lake in Cameroon were incredibly complex.
I can imagine.
Starting in 2001, they deployed a team to sink a permanent, high-density polyethylene pipe straight down into the center of the lake.
Just a giant plastic tube.
Basically, they anchored it right into that supercharged, gas-heavy bottom layer.
When I first read about this, I looked at the schematics, and the thing that totally baffled me was the lack of machinery. I kept looking for the massive electrical generator.
Right, the power source.
My immediate thought was, how do you move millions of gallons of water vertically from 200 meters down without a massive industrial engine?
The genius of the engineering is in the fluid dynamics. It utilizes a principle known as a gas lift pump, and it requires zero external power to keep running once it's started.
Zero power. How does that work?
Initially, they use a surface pump to draw a small amount of the deep, gas-rich water up into the pipe, just to get it started.
Okay, so they pull it up a bit. As that deep water is pulled upward, the hydrostatic pressure acting on it decreases.
Exactly. And just like we discussed with the eruption mechanism, as the pressure decreases, the dissolved CO2 comes out of solution and forms bubbles inside the pipe.
So inside this narrow enclosed tube, you suddenly have a mixture of water and rapidly expanding gas bubbles.
And that gas-water mixture is significantly lighter and more buoyant than the solid, dense column of water surrounding the outside of the pipe.
Oh, I see.
Because it's lighter, it rushes upward toward the surface. This creates a powerful, continuous upward suction at the bottom of the pipe, drawing more gas-rich water in from the lake bed.
It creates a self-sustaining feedback loop. The rising gas literally pulls more water behind it, creating a controlled, continuous fountain at the surface.
It shoots a massive jet of water and gas tens of meters into the air above the lake.
And it never stops.
It just keeps going. Because it is happening in a controlled, steady, vertically directed stream, the deadly CO2 simply fizzes off slowly and harmlessly into the atmosphere over time.
Instead of all at once.
Exactly. The winds catch it and disperse it in completely safe, low concentrations, rather than it surging out all at once in a dense, suffocating blanket.
Here's where it gets really interesting, because it's an incredibly elegant solution to a terrifying problem. They installed the first permanent pipe in 2001, and it worked so well that the international community funded the installation of 2 more pipes in 2011.
They literally put the lake on life support, but in reverse.
Yeah. By around 2020, they reported that roughly 1/3 of the entire lake's carbon dioxide had been successfully and safely removed. The pressure has been radically reduced.
By providing an artificial escape route for the pressure, humanity managed to take a natural, lethal mechanism and essentially domesticate it.
They bled the danger away.
It stands as a phenomenal, unheralded achievement in environmental engineering and disaster prevention.
Which begs the obvious question. This raises an important question, right? If we built a straw for Nyos, can we build a straw for Kivu? Can we disarm the monster?
We are trying, but the scalability of the Nyos victory is immensely challenging.
Because it's 1,500 times bigger.
Right. The physics of the gas lift pump work perfectly well, but the sheer volume of Lake Kivu means you would need a staggering amount of infrastructure to make a dent in 300 cubic kilometers of gas.
You'd need 1 million pipes.
Furthermore, venting Kivu's gas into the atmosphere isn't a viable solution because of the methane.
Right. You can't just spray flammable gas everywhere.
You can't just fountain tens of thousands of tons of highly flammable methane into the air over a densely populated region.
But the methane is also an incredible resource, isn't it? I mean, if you have a massive reservoir of natural gas sitting off the coast of a developing region that desperately needs power infrastructure, that risk suddenly becomes an economic asset.
The presence of the methane has spurred exactly that kind of dual-purpose engineering. There are several large-scale operations actively extracting methane from the deep waters of Lake Kivu right now.
So they're actually mining the lake.
Yes. They pump the water up, separate the methane gas, and pipe it to onshore power plants to generate electricity for Rwanda and the DRC.
What happens to the CO2?
The degassed water, which still contains a lot of CO2, is then carefully pumped back down to specific depths to maintain the lake's thermal stratification and prevent an accidental overturn.
So by harvesting the methane to power the local grid, they are simultaneously reducing the gas pressure in the deep water. They are actively fighting the bomb by using it as a battery.
It is a brilliant synergy of economic development and disaster mitigation. However, the scale of Kivu means this extraction is only partially addressing the threat.
It's just a drop in the bucket.
The deep water is still holding vast amounts of CO2, and the extraction operations themselves have to be monitored with excruciating precision to ensure they don't accidentally disrupt the stratification they are trying to preserve.
Diffusing Kivu is a highly complex, multi-generational battle.
It's a battle we are still fighting, but the critical difference is that we know how to fight it now, which is a massive leap from where we were standing on that silent, dazed morning in Cameroon in 1986.
The paradigm shifted completely from passive victimhood to active management. We moved from incomprehension to control.
Absolutely.
If we zoom out and look at this entire historical arc, the journey is profound. We started in 1986 with the absolute terror of a causeless tragedy, a morning where 1,746 people and every breathing animal for miles were just erased with no physical violence.
And from that incomprehensible silence, scientists had to deduce the existence of a completely new type of disaster.
The limnic eruption, an invisible avalanche of suffocating gas born from the bottom of a stagnant lake. We uncovered the agonizing realization that the Earth had already warned us in 1984 at Lake Manan, but we simply lacked the scientific imagination to listen.
We completely missed it.
And finally, we saw human ingenuity fight back, designing brilliant, self-powering fluid dynamic engines to literally bleed the threat out of Lake Nyos, paving the way for the high-stakes ongoing battle to manage the colossal leviathan of Lake Kivu.
The true tragedy of Lake Nyos isn't just that it happened, it's that it was a catastrophe so uncanny it should have shaken the world. But outside of scientific circles, almost no one remembers it.
People just don't talk about it.
When we forget these silent whispers of the Earth, we put millions of lives at risk. We protect ourselves by maintaining the memory of the anomaly.
I keep coming back to that visualization of the unpopped soda bottle sitting quietly on the table. The exact trigger that finally disturbed Lake Nyos in 1986, the specific rockfall or tremor or shift in water temperature, is still completely unknown.
Just a tiny shift.
A microscopic shift in balance led to the deaths of nearly 2,000 people. As we look toward Lake Kivu, a body of water 1,500 times larger, situated right next to massive human development, continuous tectonic shifting, and heavy industrial methane extraction, I want to leave you with this to ponder.
It's an important thought.
If the margin of error for limbic eruption is so razor thin, how much of our own daily activity, the vibrations of deep mining, the runoff from local construction, or even the broader, subtle thermal shifts of a warming climate, might accidentally become the tiny, imperceptible trigger for a catastrophe we're desperately, frantically trying to prevent?